So today we'll be looking at adding fractions. Now let's look at the first question then. The first question says 2 over 7 plus 3 over 7. Now a common misconception with these questions is this answer, 5 over 14. Because what people tend to do is they tend to add the numerators, which is the top numbers, and they also add the denominators, which is the bottom numbers. However, if you think about this in a practical sense, if I had these fractions representing pizza boxes, so the 7 would be the space inside the pizza box, and also here the space inside the pizza box. Now, the first pizza box, so people have eaten some pizza and there's only 2 slices left. So I'm going to put 2 dots in there. And the second pizza box, there's only 1, 2, 3 slices left. Now, in a practical sense, you want to keep these pizzas for the next day. Would you then stick both boxes, one with only 2 slices and the other one with only 3 slices, would you put both boxes into the fridge? Or would you put the pizzas into one box and then put it into the fridge? I think it makes sense to put them all into one box. So let's see what happens. Now, we did agree that this is not the right answer. So if I put all the pizzas into one box, how many pizza slices have we got left? We've got 2 in this box and we've got 3 in this box. So we've got a total of 5. Now, we've only got one box left, remember, because we're going to throw the other box away. So how many slices can a box hold? That doesn't change. The denominator stays the same. It can only hold 7. So the answer is 5 over 7. Now, simply, this was just the understanding behind it, an explanation, just so that you understand. However, all you need to do is add the numerators. So in this case, you just do 2 add 3, and you keep the denominator the same. Fantastic. Now, let's move on to the next question. 3 over 5 plus 1 over 9. Now in this question, you can see that the denominators are different. Therefore, before we can add these fractions, we need to make the denominators exactly the same. So in order to do that, let's firstly write the question out. Now, in order to make 5 and 9 the same number, I can simply multiply this fraction by 9 and this fraction by 5. Because 5 times 9 is 45. 9 times 5 is 45. Now, because we're dealing with fractions here, whatever I do to the top, I've got to do to the bottom. Whatever I do to the bottom, I've got to do to the top. So in this case, I've done 5 times 9 to the denominator. So I need to do times 9 to the numerator here. And I need to do times 5 to the numerator here. So what do I end up with? I end up with, let's start from the top. So 3 times 9 is 27 over 45 plus 1 times 5 is 5 over 45. Now you can see we've got the same situation as we had before. The denominator is exactly the same. So now we can actually add the numerators. So 27 plus 5. 27 plus 5 is 32. And obviously the denominator stays the same. So the answer is 32 over 45. Excellent. Now, let's look at the next question. 8 over 9 plus 4. Now this might look a bit tricky, but it's actually quite straightforward. Think about this logically. If I've got 8 over 9, that's a fraction, and I've got 4 whole. It could be 4 whole cakes, it could be anything, but we've got a whole number as 4. So I've got 4 of something, and I've also got 8 over 9. And that's it. That's the answer. The next question. 3 and 2 over 3 plus 4 and 5 over 7. Now this is slightly trickier than the others because we are dealing with mixed fractions. Mixed fractions are fractions that are made of whole numbers and fractions. As you can see, for example, the first fraction is 3 and 2 over 3. So you've got a whole number which is 3 and a fraction which is 2 over 3. And the same goes for the second fraction. So the first thing we need to do is we need to understand what is 3 and 2 over 3. We need to understand the fractions. So let's look at this first fraction and try to understand what they are first from this example. So 3 and 2 over 3. How else can I understand that and write that? Now, we know that we've got 2 over 3, but we've also got 3 whole ones. Everything about this fraction is based on the denominator 3. So if I show you this, 3 over 3 plus 3 over 3 plus 3 over 3 plus 2 over 3. What do you notice? That's right. The first fraction, the 3 over 3, what is 3 divided by 3? Because remember, 3 over 3 also means 3 divided by 3. What is 3 divided by 3? It's 1. The second one is also going to be the same, 1. And the third one is also going to be 1. So all of these fractions actually equal 3. That's how you get your 3 and then your 2 over 3. That's what it actually means. So if you look at it from the top, 3 plus 3 plus 3 plus 2. Because remember, I can add these because my denominators are all the same as 3. So 3 plus 3 is 6. 6 plus 3 is 9. And then 9 plus 2 is 11 over 3. And that's what the mixed fraction looks like when you convert it into a top-heavy or an improper fraction, where the numerator is bigger than the denominator. Now this is going to be an important part of this question when we start doing this question. Okay, so now that you understand what that fraction actually is and how it's based on the denominator, and what the 3 actually means, is made up of 3 over 3, 3 over 3, and 3 over 3. And when you add the numerators, you get 11, and that's over 3. We can actually start answering this question now. So instead of writing all that in the exam, you don't need to write it all out in the exam because that's going to take you time. There's a simpler way of doing this. So what you would do is you would multiply and then you add. And what I mean by that is you would multiply the denominator by the whole number, so 3 times 3 in this case, and that gives you 9. And if you then add 2, that gives you 11, and that would be 11 over 3, which is what we got before. So this fraction as a top-heavy fraction or improper fraction is 11 over 3. We can do the same now for the second fraction. So the second fraction, which is 4 and 5 over 7, if I do exactly the same thing, so if I times by the denominator and add the numerator, 4 times 7 is 7 times 4 or 4 times 7, exactly the same thing. 4 times 7 is 28. 28 plus 5 is 33. And that's going to be over 7 because our denominator stays the same as 7. So now that I've got the two converted into improper fractions or top-heavy fractions, I can now write them as a question. So 11 over 3, which is our first fraction, plus 33 over 7, which is our second fraction. Now, Can I add these two fractions? No, because I need to make the denominators the same. Now to make them the same, I can multiply this side by 7. And whatever I do to the bottom, I'm going to do to the top. And then this side by 3. So what do I end up with? 11 times 7 is 77 over 21. And then I also need to do 33 times by 3. And that gives me 99. And 99 over 21. Now can I add the numerators? Of course I can. So if I add the numerators now, what do I end up with? So I need to do 77 plus 99. That gives me 176. And over 21. Remember, I do not add the denominators in this question. Now, that is the answer, 176 over 21. But if I wanted to go further, so I could simplify this answer further. And the way I would do it is, let's do it up here. How many 21s go into 176? Now, if you do 21 times by 8, you get 168. So, if we know that 21 times 8 is 168, if you count from 168 up to 176, it's 8 extra. So therefore, the answer then would be 8 and 8 over 21, if you were to simplify it further. The big 8 represents how many times 21 goes into 176, because we said 8 times 21 is 168. Now, the 168, how much more is left to get to 176? If you count from 168 to 176, there's 8 left. So therefore, we are left with 8 over 21. So it goes in 8 times, and what's left over? 8 over 21. So 8 and 8 over 21 as the final answer. Now let's look at this problem question, because fractions questions don't always just come up as a simple fraction question where you just have to add the fractions that they've given you. Sometimes fraction questions, especially with the new exams and the new specifications, they are disguised within a worded problem. So let's have a look at this question here. Don and Zara need 1.5 litres of paint to paint a large toy model of a car. Don has 5 over 7 litres of paint and Zara has 3 over 8 litres of paint. Do they have enough paint to paint the car? So with this question, you can see that what's required is 1.5 litres. That's how much you need. And what we have is 5/7 of a litre and 3/8 of a litre. So if they both bought their paints together, then what we're saying is if we add those two values together, do we get 1.5 litres or more? Because if we get 1.5 litres or more, that means we have enough. If it's less than 1.5, then that means it's not enough. So let's have a go at this. So 5 over 7 plus 3 over 8 . So again, we cannot add this fraction. We cannot add these fractions because the denominators are different. So what do we need to do? We need to times this by 8, times this by 8, times this by 7, times this by 7. Because whatever we do to the bottom, we do to the top. So 5 times 8 is 40. 7 times 8 is 56. Plus 3 times 7 is 21. 8 times 7 is 56. So what we have here now is the denominators are the same. So I'm just going to quickly just write that because I know that's going to stay the same. And we just add the top numbers. So what do we get? We get 61 over 56. So what we need to find out here is, does 61 over 56 equal 1.5? Now what does that actually mean? Because we don't have a calculator for this question. So in order for us to do this, we need to think of it very logically. So what does that mean? 61 over 56 equals 1.5. Now that means that, can I get 156 plus a half of 56 to fit into 61? Because if I can, then I've just about got enough paint. So I'm going to say that one more time. 61 over 56, does it equal 1.5? What does that mean? What that means is, can I get 156 and a half of 56 as well to go into 61? Well, let's have a look. So what's a half of 56? Half of 56 is 28. So 56 plus 28. 56 plus 28 is 84. Now, if my top number here, my numerator, was 84, then my answer 84. So my question would be 84 over 56, and that would equal 1.5. Now what we've got to ask ourselves is, do they have enough paint? Now for them to have enough paint, they need to have 1.5 litres, and for there to be 1.5 litres, the numerator has to be 84 or more, as we can see. Is it 84 or more? No, it isn't. So because it's 61, it's less than 84, so it's going to be less than 1.5, the answer. So therefore the answer would be 9 of paint.